When I first volunteered to do the TEDx conference and speak about my modules, I wasn't aware that I was supposed to be speaking about my modules. So I created I do CAD programs, which is computer automated design, or computer aided design, I apologize. And it's not really my modules, but it is something that I enjoy doing. And it's a really cool thing with lots of applications in the real world. Some of you may know I was on the robotics team this year, and we used a CAD program, which is called Autodesk Inventor, to design and build the robot for the year, and we came in 3rd place in the competition. With that, I'll get started with this PowerPoint. So the first thing of a CAD program is it uses a computer to help you design products or whatever you really want to design. You'll see later I designed a trebuchet, and I'll show you how that works, and stress analysis and all that kind of stuff. One of the main things about Autodesk is that you don't waste materials when you build it, because you only need to build something once. It's already been built completely in this CAD program, and you don't need to waste materials trying to figure out what does what, how it interacts with other things. That's what the finite element analysis is for. It's basically just showing how the product you've made will interact with the environment. It shows how the stress on this, where the stress is, how much stress is there, and how it reacts to that. Dynamic simulation is if you were to put it into the real world and activate it, or give it gravity and all this other kind of stuff, and it'll show you how it will interact in the world. And another use of AutoCAD that's really great with it is when you want to build something, you have to go and you give it to a manufacturer. Usually it's a machine shop. And with Autodesk Inventor, you can create a drawing in the CAD program, and it will basically give you everything that you need to give to the machine shop right off the bat, and you don't really have to mess with it all that much. And I'll come to the instructions at the end. So I talked about the material waste. It's really helpful in saving materials. Last year, or this coming year with the robotics, we kept on building a robot. We would build it out of wood, and then something would break, and we had to build it out of a different type of wood, and that would break as well, or it wouldn't interact how we want to interact with the other parts in the robot. So we went to AutoCAD, and we designed everything in AutoCAD, and we built it the first time, and it worked amazingly well. Okay, this is the dynamic simulation, which is once again showing how something operates in the real world without having to build it yourself. Once again, helps with the material waste. Matt, would you mind switching to the Autodesk itself? So this is the Autodesk simulation player, and what it's going to do is it's going to show you how this trebuchet would interact if we were to let it run in the real world. This is in slow motion film, so it might be a little bit weird. Let's see the mouse. Now, what you can see here is you have this ball and the weight falling, and you can trace the ball with the program and see how it's going to interact when it shoots out. Let me zoom out for you. Uh-oh. And you can see how it's going to shoot out, and what you can do with this tracing program is you can find out the x-axis and the y-axis. You can find out at its peak, how high is it, and at the peak of its vertical distance, you can find out how far it would launch, which is really great for knowing if you need it to launch so far and this doesn't make it, you don't have to build it again. You can just go back to the drawing board with this and maybe change the weight or change the arm length and all that kind of stuff. Back to the PowerPoint, please. Okay, so that was dynamic simulation. The next thing is a finite element analysis. And this is basically a stress analysis of the part that you've made. It will help you to decide whether it's going to handle the amount of loads that you need it to handle, or if it's going to break under those pressure. Go back to Autodesk, please. Now. So this is the arm of the trebuchet. It'll pop up. Where is it? There it is. Okay. So this is the arm that is in between. It's the first of the two arms. It does not actually hold it. What it's holding is the weight. And so these two forces are each representing 200 pounds of pressure in that spot. This is, you can set the material. You can set it for wood, and it'll show you that it's snapped right in half in the middle there. What we made it for with the robot would be aluminum 6061, which is aircraft grade aluminum, so that's what I set it for in the program. And then if I come up to here, we can actually see how the weight will affect the amount of pressure. Now it's going to run this simulation. It might take just a little bit. In the meantime, what it does is it's calculating a mesh, which is little tiny pieces of each part. And so if I give you let me give you the mesh view really quick so you can see what I mean by calculating a mesh. So each of these little tiny triangles, which are a little bit hard to see, is one part of the structure. You can make those triangles bigger or smaller depending on how detailed you want this simulation to be. Now as you can see, as it's bending here, you get the scale over there with how much pressure, how much it can withstand. At red, it turns to a breaking point, but right now, it's in the blue. For this, I set up the center to be constrained, which means it won't be moving on the center hole there. And with 200 pounds on each force, this part would stand up fairly well. It would bend a bit, but it would not break. Matt, would you mind going back to the slide one more time? So, and then that would give you an idea of if you want to use wood and keep it nice and light, but using wood in that kind of scenario, it would break. So you would say, well, maybe we should use iron, and you see that it stands really well, and you don't want it to be too heavy, so you would go back to aluminum 6061, and that'd be your middle point. And then the next thing is that you can put into a machine shop, which is what I was talking about earlier. When you build a part, you're going to take it to somebody who needs to manufacture it. And for that, they're going to need a plan. And that plan is, that. This is just one of the parts that was on our robot last year. It's a triangular plate. And they can tell from all these crazy markings exactly where they need to drill holes, where they need to cut out the pieces, and exactly how it needs to work. So that is something that we gave to the machine shop last year, and I wish I could find the part that we had, but it turned out really well, and it looked perfect just as it did in the CAD drawing itself. So this is, I'll just give you a little quick run through. This here is going to tell you how big the hole is, if it's going to be threaded, which means it's going to have little screws that you can screw bolts into, or if it's going to be straight. It'll also tell you the thickness of the hole. Like for these, they went in about ½ an inch into this piece. And so that was marked in the drawing. I think that's marked down here as well. And then it also tells you the height, the size, where the holes need to be drilled. And what they do is they'll put it onto a little machine, and they'll simply plug in the numbers, and it will do this all for them because you had it in CAD and you drew it out. Earlier, before CAD programs, you would have to take hours drawing just this one thing to make it to scale, perfect, the right length, all the right numbers in the right place. And then the last thing that I want to show you is the instruction booklet. With CAD programs, you can do stuff that you can't really do. I know a lot of you have put together furniture, and you can probably tell how frustrating that is when you're reading the instruction book and you're going, how does this piece fit where? And so with CAD, what you can do is this. This is going to be the trebuchet once again. And this is in Adobe Flash Player. You take the CAD program, you transport it here, and you will play this, and it'll show you exactly how to assemble and disassemble the trebuchet. So just take a look. Now you can probably imagine how useful this would be when you're putting together your couch. If you had step-by-step instructions that were in a video format like this, it would likely be a lot easier. This was all done with Autodesk Inventor and Autodesk Inventor Publisher, which was the program that allowed to do this. I made an Autodesk Inventor, and then I sent it to this program, and I helped it figure out how things go where and where they go. Now that is how you put together a trebuchet. Thank you guys for listening. Like I said, this isn't really my modus, but I had fun doing it.